For question 35, the answer is D. If we refer to Table 2 and compare trials 10 to 11, we notice that all the variables are constant except weight, suspended, and frequency. Although frequency is different, 300 and 150, weight suspended is much greater, has a much greater variance of 900 and 225. Also going back to option B, resulting vibration is an effect, which is a dependent variable, and that's not exactly what we're looking at because we want to know what is directly manipulated. For question 36, the answer is G. By reading the first paragraph for experiment 1, in yellow we see highlighted that making the tension in the string equal to the suspended weight in newtons, that shows us that the only variable that would produce a constant tension would be the weight suspended. For question 37, the answer is D. The best way to answer this question is to compare trial 10 to trial 13. Besides the material, we can see that the length and the mass density are the same as trial 13, so therefore it's going to produce the same frequency, and especially because the suspended weight is larger, as weight increases, frequency is going to increase, so the only option that would make sense would be 600 Hertz. For question 38, the answer is F. By comparing the column of frequency and the other variables cited in each answer, you are able to work through and eliminate answer choices. So this is kind of just compare and contrast, and we can see that the only relationship that is evident here that would make sense would be F. As we increase tension, the frequency observes in almost every single case. For question 39, the answer is B. If we refer to trials 8 and 11 on table 2, since they are all nylon, we find the lowest frequency, which is 75, and it's circled, and read the chart, we find that the highest mass would be the 40 grams per meter. That's the mass density, but that's therefore going to give us a mass, as density and mass are proportional to each other. For question 40, the answer is F. If we look at table 1, we're looking at the steel string. This question requires you to add provided information to the existing chart and look for a pattern. By adding a trial 7A and using the numbers provided, a pattern will emerge that shows the vibrating length to be 0.5. Another way to think about this is if we look at table 1 and, in fact, table 2, there is no vibrating length that's different than 0.5 or 1. So if we look back at our answer choices, it would be hard for the author of this passage to really make an answer that wasn't one of those two, because it would be hard to really compare data and make a safe assumption.